What if one rusted machine from the bottom of the sea makes the clean story of human progress impossible to keep simple? Most of us carry a picture of history that feels natural. First came simple stone tools, then bronze, then iron. Then cities rose and writing appeared, and science began. Much later, someone built the first real machines, and only in the last few centuries did those machines become complex enough to calculate. It is a tidy ladder. Each rung follows the one before it. The ancient world made beautiful things, but it did not make computers. That picture held until the year 1900, when a group of sponge divers took shelter from a storm near a small Greek island called Antikythera. They found a shipwreck, and inside that wreck, among bronze statues and pottery and the ordinary cargo of a lost Roman-era vessel, someone noticed a lump of corroded metal that looked like nothing in particular. It was a chunk of hardened sediment with what appeared to be gear teeth embedded in the surface. That lump sat in a museum for decades while scholars argued about what it might have been. Then, in the 1970s, researchers used X-ray and gamma-ray imaging to look inside the corrosion. What they found rewrote the history of technology. Inside the bronze fragments was a system of interlocking gears, more than 30 of them, precisely cut, arranged in layers, turning on axles. The gears modelled the movements of the sun, the moon, and the visible planets. They predicted eclipses. They tracked the 4-year cycle of the ancient Olympic Games. The device was not a clock in the modern sense, but an analog computer designed to compress the heavens into a portable bronze box. When you turned a single knob on the side, the dials on the front and back moved through time. You could set a date and watch the sky unfold. This was not supposed to exist. The simple ladder of progress says that machines of this complexity belong to a much later era. The gears alone required an understanding of ratio, of metalworking at small scale, of astronomical cycles so precise that the device could account for the moon's irregular orbit. Someone had to design the gear trains. Someone had to cut the bronze teeth by hand. Someone had to calibrate the whole system against real observations of the night sky. Someone had to teach all of this to the next person. And the object we found was not a prototype. It was a refined, miniaturized, functional device. The craftsmanship was mature. Now the picture becomes uncomfortable. If a machine this complex existed once, it was almost certainly not born alone. It points backward, to earlier versions that did not work as well, to the workshops where the tools were made, to the teachers who passed down the knowledge of gear ratios and celestial cycles, to a whole technical tradition that must have existed for generations before anyone could build a device this sophisticated. And that tradition is almost entirely missing from the surviving record. There are no instruction manuals, no diagrams of gear trains, no apprentice exercises, no failed prototypes, just this one corroded machine from the bottom of the sea. The mechanism survived only because it sank. Wood rots, papyrus crumbles, metal can last for 2,000 years underwater if the conditions are right. What else was built that did not sink? What else was made from materials that did not survive? The real mystery is not the object in the glass case. It is the world that must have surrounded it. The workshops, the knowledge, the hands that cut the gears. If this mystery pulls you in, like subscribe and tell us where you're watching from. To understand the scale of what was lost, we need to look closer at what this machine actually did. The gears did not simply spin. They encoded a working model of the sky that was centuries ahead of its time. Inside the corroded bronze, researchers found a system of gears that turned the sky into a mechanical model. Think of it as a portable planetarium. You turn a handle on the side and the sun, moon and planets move across the dials in real time, not as a guess, not as a rough sketch, but as a calibrated prediction. The device could track eclipses. It had a dial dedicated to the Olympic cycle, the 4-year rhythm that organized Greek life. It modelled the moon's uneven motion using an ingenious pin and slot mechanism that accounted for lunar anomaly. The gear teeth were cut to millimetre precision. And modern X-ray imaging has revealed inscriptions, a kind of user manual, etched onto the bronze plates. All of this was built around the year 100 before Christ. The standard picture of ancient technology does not have room for a machine like this. We learn about simple tools, levers, pulleys, perhaps a water clock. Then the story jumps to the medieval era before complex geared devices reappear. But here, in a shipwreck, is a device that compresses astronomy, mathematics, and fine metalwork into a single handheld instrument. It is not a rough prototype. It is a finished, refined product. And that is where the real puzzle begins. A device this sophisticated cannot be a lone invention. It required a lineage of artisans who understood gear ratios, who could cut bronze teeth with consistent precision, who knew the cycles of the heavens well enough to encode them into wheels and dials. There must have been teachers, apprentices, failed earlier versions, tools, workshops, and a living tradition of mechanical astronomy that passed from hand to hand. Yet that tradition is almost entirely missing from the archaeological record. We have the finished machine. We do not have the workshop floor, the discarded prototypes, the instructional manuals, or the names of the people who built it. The Antikythera mechanism appears in history as a single, isolated miracle. But it was never born alone. The real shock is not just that the mechanism existed. The shock is that its technical family tree has vanished. We are left with one surviving object, salvaged by accident from the seafloor. And that object forces us to accept that ancient technical skill reached higher than the standard timeline suggests. But it also raises a sharper question. Why don't we see more? Where are the other machines? Where are the workshops that should have surrounded this one? One answer is that the fragile parts of a civilization do not survive. Wood rots, textiles decay, parchment burns, libraries crumble. The knowledge that lived in human hands and in organic materials disappears when the chain of teaching is broken. Only the heavy, durable objects, the bronze, the stone, the fired clay, have a chance of outlasting the collapse. So the Antikythera mechanism may not be a miracle. It may be a survivor. The last visible piece of a much larger technical world that left almost no other trace. To understand how that can happen, we need to think about what a collapse really erases. From the corroded bronze of a single machine, we step back to ask a wider question. Not about what was found, but about what could ever be found at all. Imagine our own civilization, not as it feels right now, but as a future ruin. 1,000 years after the power grids fail, after the data centers go dark, after the last server room floods and the last backup drive corrodes. What would an archaeologist from that future actually see? They would not find our knowledge. They would not find the internet, the manuals, the factory blueprints, the software that ran the machines. Hard drives decay, plastic warps, paper rots, or burns, or dissolves into wet pulp. Even the most carefully stored digital archive becomes unreadable long before the stone around it crumbles. But they would find concrete. Lots of it. Broken shells of buildings, silent dams, tunnels bored through mountains, the stumps of bridges. They would find heavy things. Metal skeletons of skyscrapers, rusted but still standing, their glass long shattered and scattered. They would find monuments, statues with missing faces, engraved plates whose inscriptions have worn smooth. They might find an observatory dome, its telescope long gone, its purpose guessed but never truly known. And they would try to make sense of us. They would notice that we built enormous structures near water, near coastlines, near rivers. They might conclude that we worshipped water, or that our leaders demanded giant empty halls for reasons of power. They might see a hydroelectric dam and interpret it as a ritual wall, a barrier against imagined enemies, because the turbines that once spun inside would have rusted into unrecognizable lumps. The wires that carried electricity would be gone. The generators would be silent shells. The knowledge of how it all worked, the engineering, the physics, the daily maintenance, would vanish with the people who understood it. Because knowledge is not heavy, it does not fossilize. It lives in brains and hands and fragile media, and when the chain of teaching breaks, it disappears as completely as a voice in an empty room. Now take that thought and turn it backwards. If a future archaeologist could misread our dams as ritual walls and our observatories as temples, what are we misreading when we look at the ancient world? The Antikythera mechanism did not come from nowhere. It was the product of workshops, teachers, failed prototypes, tools, and a living tradition of mechanical astronomy. But almost all of that tradition is gone. The bronze gears survived because they sank into the sea, away from the recycling fires that melted down most ancient metal, away from the wars, the collapses, the simple passage of time that erases the lightest things first. This is not a claim that a lost super-civilization once ruled the Earth. That would be too easy, and the evidence does not support it. The quieter, harder idea is this. The archaeological record is not a complete library. It is a sieve. It catches stone, metal, and sometimes glass, but it lets almost everything else pass through. Wood, cloth, leather, papyrus, human memory, these things dissolve. What remains is not the whole story. It is the heaviest fraction of the story, the parts that refuse to rot. So when we find one bronze machine that should not be alone, we are not looking at an isolated miracle. We are looking at the one object that got lucky. The workshops that built it, the earlier models that taught its makers, the manuals that explained its use. All of that may have existed and then vanished, not because it was never there, but because it was made of things that do not survive. This changes how we read the past. It does not give us permission to invent whatever we want, but it does give us a reason to pause when the surviving record seems too simple. The absence of evidence is not evidence of absence. It is quite often a consequence of what preserves and what does not. With that understanding, we can now look at ancient stonework with new eyes. If bronze can vanish almost completely, what about stone that was built to last? In the Andes, far from the Mediterranean, there are stones that do not look like rough monuments. They look like components, cut, shaped, and fitted with a precision that feels less like simple labour and more like something engineered to outlast the people who made it. So the Antikythera mechanism survived because it was bronze, because it sank, because it lay in sea mud for 2,000 years while the world above forgot its own past. But survival is only half the story. The other half is the world the machine came from, the hands that made it, the minds that taught those hands, and the workshops that now leave no trace. Consider what it takes to make a mechanical watch today. Not one person working alone, but a network. Designers who calculate gear ratios, metallurgists who refine alloys, jewelers who set bearings, assemblers who fit tiny parts under magnification. The Antikythera mechanism required a similar chain. Someone had to understand the movements of the sun, moon, and planets well enough to reduce them to gear teeth and rotating dials. Someone had to cast bronze blanks, file them smooth, drill axle holes with precision, and test the whole assembly until the heavens turned in a box. If you found a single Rolex in a shipwreck, you would not assume it was the only watch ever made. You would assume a factory, a brand, a tradition, a line of earlier models that taught the makers how to reach that level. No one invents a fully formed precision instrument from nothing. There must have been prototypes that failed, simplified versions for teaching, manuals that described the gear trains, and apprentices who spent years learning from masters. Yet the archaeological record is almost silent. No earlier Greek astronomical devices have been found. No workshop floor littered with bronze filings and broken gears. No apprentice piece with slightly misaligned teeth. No manual written on papyrus explaining how to cut a gear train for the synodic cycle of Venus. The Antikythera mechanism appears in the record as a finished object, already perfected, already working, as if it arrived without a childhood. The bronze itself tells part of the reason. Metal is valuable. It can be melted down and reused. A broken gear is not a failure to be buried in a museum. It is raw material for the next casting. Wood decays, leather crumbles, papyrus burns or rots in damp soil. The fragile things that carried the instructions, the records, the teaching, the memory, they are the first to disappear. What remains is the dense, durable object that sank before anyone could recycle it. So the missing workshops are the real ghost, not the machine. The machine is the one piece that escaped the recycling, the decay, the forgetting. It is not an anomaly in the sense of being impossible. It is an anomaly in the sense of being almost alone. It suggests a technical tradition that may have lasted for generations, producing perhaps dozens of similar devices, each one teaching the next maker a little more about how to shrink the cosmos into a palm-sized mechanism. And if an entire technical tradition could vanish from the ancient Mediterranean, leaving only one corroded bronze box as evidence, then a larger, more unsettling question opens. What else could have disappeared from other times and other places? What specialized knowledge, mastered over centuries, might have been lost when a single city fell, when a single school disbanded, when a single line of teachers died without successors? The Antikythera mechanism becomes more than a curiosity. It becomes a symbol of lost technical memory, a reminder that the objects we find are not the full inventory of what once existed. The viewer who holds this symbol now carries a new lens. They are no longer looking at ancient ruins and wondering only how they were built. They are asking what invisible chain of knowledge once stood behind them, and how much of that chain has been erased. Let us test that expectation. Far from the Greek seas, in the thin air of the Bolivian highlands, there is a place where the stones themselves seem to speak a lost technical language. It is called Puma Punku, and the questions it raises are not only about moving blocks, but about shaping them as if they were parts of a larger machine. High in the Bolivian Altiplano, the air is thin and the ground stretches flat under a pale sky. Near the southern shore of Lake Titicaca, the ruins of Puma Punku lie scattered across the earth like a broken machine. The blocks are not small. Some weigh over 100 tons. They are made of andesite, a hard volcanic rock that resists a chisel. Yet their edges are sharp, their faces flat, and their corners cut to precise right angles. Recesses and grooves run along the surfaces as if each stone was shaped to receive another. Think of Stonehenge. Massive stones, rough and heavy, dragged upright by human effort and shaped just enough to stand. Now imagine those same weights, but with flat planes, sharp internal corners, and interlocking cuts that would not look out of place in a modern factory floor. That is the first shock of Puma Punku. Walk among the ruins and the details multiply. There are H-shaped blocks, symmetrical and clean. There are smooth, polished surfaces on stones that have endured centuries of wind and frost. There are perfectly round drill holes, some just a few millimeters wide, bored deep into the rock. There are complex joints, dovetails and sockets that lock one heavy block into the next with the logic of a wooden puzzle. The standard explanation says the Tiwanaku people, who built this site more than 1,000 years ago, used stone hammers and bronze chisels. Against andesite, that is a slow, grinding labour. It is not impossible. But the consistency of the forms, the repetition of the same exact shapes across many different stones, makes you pause. It is one thing to shape a single block with patience. It is another to repeat that precision dozens of times, across pieces that had to fit together as part of a larger plan. The usual question is how they moved such weight. But a quieter, more uncomfortable question rises here. Why did they shape the stones this way at all? If the goal was simply to raise a wall or lay a platform, rough heavy blocks would have served. The additional effort of cutting precise angles, of polishing surfaces that would be hidden in a joint, of carving sockets that demand a matching tenon elsewhere, that extra work cost time. Every day spent refining a stone was a day not spent hunting, planting, or repairing a shelter. Something had to make that cost worth paying. The stones start to look less like building materials and more like components. Not just blocks for a wall, but elements of a system designed to fit together with a mechanical intention. The H-shaped pieces, the recessed grooves, the repeating modular forms, they suggest a builder who was not just stacking, but assembling. This is where Puma Punku becomes harder to dismiss. It does not prove lasers or lost high technology, but it does force you to respect the mind behind the work. The planning, the measurement, the transfer of a design from one generation of hands to the next, that is a technical tradition. And like the bronze gears of the Antikythera mechanism, that tradition feels more advanced than the simple ladder of progress expects. Puma Punku was not an isolated wonder. It was part of Tiwanaku, a city that once spread across the high plain, coordinating labour, food and belief across an entire landscape. The scattered stones we see today are only the surface. To understand what was lost, we need to step back and look at the civilization that shaped them. Puma Punku was only one piece of a much larger puzzle. The broken blocks and scattered sockets belong to a city that once spread across several square kilometres. Temples built on massive platforms, sunken courts lined with carved heads, and a drainage system that channeled water through stone channels beneath the streets. This was Tiwanaku, a place that held power in the Andes for centuries. Think about what it takes to build a modern skyscraper. You need architects who can draw the plans, surveyors who can read the land, stonecutters who can shape hard material, and transport teams who can move heavy loads. You need a shared set of measurements, a language of angles and tolerances that every worker understands. Without that invisible structure, the visible building cannot rise. Tiwanaku must have worked in a similar way. The builders used andesite, a volcanic rock that is difficult to carve. They brought it from quarries up to 10 kilometers away, across uneven ground without wheels or draft animals, and they did not simply pile it up. They cut it into repeated forms, standardized H-shaped blocks, identical sockets, matching grooves that appear again and again across the site. That repetition is not the mark of improvisation. It is the mark of a codified design, a tradition passed from teacher to student, a system of quality control that we rarely associate with societies this old. And that is where the familiar story begins to feel thin. We are not only looking at heavy stones moved by muscle, we are looking at a chain of specialized knowledge, planning, measuring, cutting, fitting, teaching. The stones are the surviving skeleton of that chain. Remember the missing workshops behind the Antikythera mechanism. The bronze gears pointed back to a tradition of mechanical astronomy that left almost no other trace. Tiwanaku presents the same problem in stone. Around 1,000 years ago, the city collapsed. The platforms were abandoned, the drainage channels filled with silt. And when the social order that supported the stonecutters came apart, the knowledge of how to work and andesite with such precision likely died with the last master craftsman. The stones remained. The instructions did not. This is not a claim about lost lasers or alien tools. It is a quieter and more unsettling observation. Sophisticated technical knowledge can vanish when the system that feeds it breaks. A skill that took generations to develop can disappear in a single century of disruption. What we see at Tiwanaku is the object without the operating manual. If stoneworking at this level could fade away in the Andes, what else might have been lost in other parts of the world? What other skills, what other recipes, what other ways of reading the landscape or the sky might have dissolved without leaving a single written word? Tiwanaku reinforces a pattern that we have already begun to trace. A civilization can reach a height of technical ability and then lose it. The later Andean cultures, the Inca among them, built their own monuments, but they did not replicate the precise andesite joinery of Tiwanaku. Something had been forgotten. But this kind of precision is not confined to the high plains of Bolivia. On the other side of the world, in India, ancient caves offer a different kind of stone mystery. Not the puzzle of moving giant blocks, but the puzzle of polishing rock until it behaves almost like a mirror. The next trace is not a city. It is a hill of carved and polished stone. From the high Andes we travel to the Indian subcontinent to a place where stone was not just shaped but refined to a mirror finish. The stone at Puma Punku was cut with geometric precision, but here the stone was transformed into something that feels almost liquid under light. In the hills of Bihar, India, there are caves that feel less like natural shelters and more like architectural chambers. The walls are so smooth they gleam. Every sound seems to linger. These are the Barabar caves. Imagine a cave. Not a rough, jagged hollow carved by water over millennia, but a room where the walls are polished to a smoothness you would expect on a modern countertop. And the room is carved from solid granite, one of the hardest stones on earth. Granite is unforgiving. It contains quartz, feldspar, and mica. It does not yield to chisels easily. To polish it to a reflective finish requires a sequence of abrasive materials, each finer than the last, applied with steady pressure over countless hours. The people who did this work had no steel, no diamond abrasives. They used sand, stone, and immense patience. There are 4 main chambers here, each carved around the 3rd century before Christ, during the time of the Mauryan Empire. Their shapes vary. One is rectangular, another oval, a third is a long hall. But they share a common feature. The granite surfaces are polished to a mirror finish. Run your hand over them, though you cannot, and you would feel glass, not stone. The reflected light moves like water across the curved ceilings. You step inside, and the world changes. The heat of the Indian sun gives way to cool, still air. The noise of the forest is replaced by a deep silence, broken only by the sound you bring. And then there is the sound. A sustained note in these chambers can echo for several seconds. Clap your hands inside and the sound returns to you, shaped by the polished walls. The space amplifies certain frequencies. It creates an almost otherworldly auditory experience. It is not just an echo, it is a resonance that seems to hold the air itself. In the oval chamber, a hum can travel around the curved wall and return from a different direction. In the long hall, the sound seems to stretch before it fades. It is as if the room itself is tuned. This was not accidental. The builders intentionally shaped the stone to manipulate sound and light. They created an immersive sensory environment. Every curve, every polished surface was part of a design meant to alter perception. The question is not just how they achieved this polish with ancient tools, but why? What purpose drove them to spend months or years refining a surface that could have been left rough? The chambers could have served as shelters or storage with far less labour. but someone chose to make them shine. The Barabar caves reveal that ancient stoneworking was not only about structural integrity, it was also about creating a controlled sensory experience. This adds a new dimension to our understanding of ancient technical skill. The builders were not just masons, they were shaping light and sound as deliberately as they shaped stone. They were, in a sense, engineering an experience. To understand why someone would spend so much effort polishing a cave, we need to look at the culture that produced it, the Mauryan Empire and its ascetic traditions. The Mauryan Empire, under Emperor Ashoka in the 3rd century before Christ, was a time of religious ferment. Buddhism and other ascetic movements spread across the subcontinent, and the ruling elite sponsored the creation of spaces meant for silence, for meditation, for turning inward. It was out of that world that the Barabar caves were carved, not as rough shelters, but as chambers designed to alter perception. Imagine a modern meditation hall built for tranquility. Soft light, minimal distraction, a sense of isolation from the outside world. The Barabar caves may have served a similar purpose, but they were not constructed from wood and cloth. They were cut directly into living granite, then polished until the walls became dark mirrors. The effort required to achieve such a finish is difficult to overstate. Granite is hard and unyielding. To turn its surface into something that reflects light demands not only skill, but an immense investment of time and labour, months, perhaps years of patient grinding, smoothing and polishing. The result is a room where the stone seems almost liquid, where the dim glow of an oil lamp shimmers across every wall and ceiling, dissolving the boundary between solid and void. But the experience went beyond sight. The polished curves of the chamber also shaped sound. A voice spoken inside one of these caves does not die quickly. It lingers, echoes, and returns with a strange clarity. A chant or a mantra repeated in that space would become a resonant chorus, as though the stone itself were singing back. This was not an accident. The builders understood that the room could be tuned, that the acoustic properties of polished granite could amplify and sustain sound in ways that a rough cave never could. This is not merely craftsmanship in the ordinary sense. It is something closer to a technology of the senses. The stone was being used as a medium to engineer a specific experience, a shimmering visual field, a resonant soundscape, a feeling of being enclosed in something otherworldly. The intention was not just to provide shelter for monks, but to create an environment that could shift perception, that could make the familiar world feel distant and thin. If ancient builders could manipulate stone to shape light and sound so deliberately, then what other materials did they master in ways we are only beginning to rediscover? The Barabar caves hint at a kind of practical knowledge that went far beyond simple utility, a knowledge of how materials behave, how they interact with the human senses, and how they can be transformed to produce effects that feel almost magical long after the original purpose has been forgotten. That question widens the investigation. We have seen a machine that calculated the sky, and stone shaped with an engineer's intent. Now we see a chamber that manipulates perception itself. The pattern is not one of isolated genius, but of traditions that understood materials deeply, traditions that could vanish, leaving behind only these silent, polished rooms. And if stone could be engineered for sound and light, what about other materials? Could ancient artisans have created effects in glass or metal that modern science took centuries to explain? That question leads us to two remarkable objects: a Roman cup that changes colour and an iron pillar that refuses to rust. From the polished granite chambers of India, we turn to a delicate glass cup that holds a secret in its very substance. In the British Museum, there is a small Roman glass vessel from the 4th century after Christ. It is a cage cup, carved with a scene from mythology, King Lycurgus entangled in vines. But its most striking feature is not the carving, it is the colour. Lit from the front, the cup glows a calm jade green. Lit from behind, the same glass turns a deep ruby red. Hold a candle inside it, and the whole object transforms before your eyes. The change is not painted on the surface, it lives inside the glass itself. The secret is suspended in the material, tiny particles of gold and silver, so small they can only be seen with an electron microscope. When light strikes these particles, they scatter it differently depending on the angle. The technical name for this is dichroic glass. Modern science only began to understand the physics behind such effects in the 20th century. Yet a Roman workshop, somewhere in the late Empire, held this effect in their hands 1600 years earlier. They did not know about nanoparticles. They had no theory of surface plasmon resonance. But they had something just as powerful, a recipe, a precise mixture of raw materials, heated to specific temperatures, cooled at specific rates, repeated until the glass behaved the way they wanted. One batch might fail, the next might shift to amber or blue, but the workshop kept the successful formula and passed it from master to apprentice, hand to hand. What is remarkable is not that they stumbled upon a curious effect. Ancient craftsmen discovered many things by accident. What is remarkable is that they kept it, that they stabilized a process complex enough to produce a consistent dichroic response, and that they valued the result enough to carve it into a masterpiece. This cup is the only complete Roman dichroic glass object known to survive. It is a single survivor of a lost recipe chain. The cup is not evidence that Romans practiced nanotechnology as we understand it. It is evidence that a workshop tradition can achieve a level of material control that science later explains, but does not predict. The knowledge was practical, not theoretical. It lived in the hands and the kilns, not in equations, and when the workshop closed, when the last master died without a successor, the cup remained while the instructions vanished. That is the quiet shock inside this small glass object. A craft tradition can climb to a peak of sophistication without leaving a single, written explanation behind. The object itself becomes the only record. If a glass workshop could preserve such a sophisticated recipe without understanding the physics, what other practical knowledge might have been hidden in ancient crafts? How many other recipes produced effects that we now call modern science, but that were first known in a furnace or a forge and then lost when the fire went out? The Lycurgus Cup is not alone. The pattern of ancient material mastery appears again, in a different material and a different continent. In India, a massive iron pillar has resisted rust for over 1,000 years, a different kind of ancient material puzzle, and the next trace in our investigation. In the courtyard of a mosque in Delhi stands an iron pillar that has quietly baffled metallurgists for generations. It was forged sometime around the 4th or 5th century after Christ, and it towers more than 7 meters above the ground. The pillar weighs over 6 tons, and after 16 centuries of standing in the open air, through the burning heat of summer and the pounding rains of the monsoon, its surface shows only a thin, dark film of rust. Most iron does not behave this way. Modern iron, when left unprotected against rain and humidity, rusts away in decades. It swells and flakes and eventually crumbles. But the Delhi pillar has endured century after century of wet seasons with barely a mark. The iron has not disappeared. The shape has not collapsed. And for a long time, nobody could fully explain why. The answer turned out to be locked inside the metal itself. When scientists analysed the composition of the pillar, they found something unusual. The iron contained a relatively high level of phosphorus. This was not an accident of corrosion. It was a direct result of the specific type of ore that the ancient ironworkers used and the way they processed it. The phosphorus, combined with the iron and the wet-dry cycling of the climate, encouraged the formation of a very thin protective layer. Scientists call it a passive film. In simple terms, the surface of the pillar created its own shield. Once that shield was in place, water and oxygen could no longer easily attack the metal beneath it. The ironworkers who built this pillar did not have microscopes. They did not have modern chemistry. They almost certainly did not know the molecular structure of the protective layer they were creating. But they knew something else. They knew that a certain kind of ore from a certain location, when heated and hammered in a certain way, produced iron that refused to rot. That knowledge was not written in any textbook that survived. It was not preserved as a formula. It was preserved as a practice, a recipe, a chain of hands. And that is exactly the pattern we saw with the Lycurgus Cup. The Roman glassmakers who produced that colour-shifting goblet did not know they were suspending nanoparticles of gold and silver in glass. They knew that a particular mixture, fired at a particular temperature, gave a particular effect when light passed through it. The recipe worked. The theory did not need to be known. The cup and the pillar are separate objects, separated by thousands of miles and hundreds of years, but they carry the same kind of message. They are pieces of practical knowledge frozen in material. The workshop tradition that produced them could achieve results that modern science would later explain, but the tradition itself could vanish. When the last craftsman died without a successor, the recipe died too. The object remained silent and puzzling until people with new instruments could finally decode what the makers had known only with their hands. If that is true for a cup and a pillar, the question begins to stretch. What other knowledge might be hidden inside the objects themselves? What if some of the largest and most famous ancient structures are not just monuments, but containers of a lost understanding? Could a building encode a function that we no longer recognize, because the people who understood that function are gone and the fragile parts of their knowledge dissolved long ago? The cup changes colour. The pillar resists rust. Both are small hints. They are not proof of a global technological empire. They are proof that practical mastery can exist without modern language, and that mastery can be lost. Now the investigation must grow in scale. If material recipes could be hidden in glass and iron, then perhaps something larger was hidden in stone, and the next trace is not small. It is a mountain of cut rock that has stood on the edge of the desert for more than 4,500 years, the Great Pyramid of Giza. It is so vast and so precise that it forces us to stop and ask a different kind of question. Not just how it was built, but what it was built to do. A Roman cup that turns from green to red when light catches the glass. And an iron pillar in Delhi, standing in the open air for roughly 1,600 years, still largely uncorroded. Two objects, two materials, one quiet pattern. Think of it like a family recipe. A grandmother knows exactly when the dough is ready, what temperature the oven needs, how long to rest the mixture. She cannot write a chemistry paper on gluten cross-linking or Maillard reactions, but the cake comes out perfect every time. The knowledge is real. It works. It just does not speak the language of the laboratory. The Lycurgus Cup contains tiny particles of gold and silver, smaller than the wavelength of visible light. When light passes through the glass, these nanoparticles scatter it in a way that shifts the colour from green to red. Modern science calls this surface plasmon resonance. The Roman glassmaker almost certainly did not know that term. But someone, in a workshop now long gone, mastered the recipe, the exact mixture of metal dust, the temperature, the timing that produced this effect. The craft chain preserved the knowledge. The theory came later, by nearly 2,000 years, and that is a crucial difference. We are not saying the Romans had a secret nanotechnology program. We are saying that practical hands-on knowledge can encode effects that we later explain with advanced science. The object holds the knowledge, even when the words to explain it are lost. The Delhi iron pillar tells a similar story, not through embedded particles, but through a remarkable resistance to rust. Analysis shows that the iron contains a relatively high amount of phosphorus, and that the surface has formed a thin, protective layer of iron hydrogen phosphate hydrate. This layer acts as a barrier, slowing corrosion dramatically. Did the ancient smiths understand the electrochemistry? No. But they knew, through generations of trial and error, that certain ores from certain mines, processed in certain ways, produced metal that would outlast a lifetime. The recipe was the science, and when the workshops that held that recipe disappeared, the knowledge dissolved. But think about what this shift in perspective does. If a small cup and a single pillar can encode functional knowledge that survives the loss of language and theory, then what about something larger? What about a monument? If a glass vessel can hide a secret of light that took 2 millennia to explain, what might a structure weighing millions of tons, aligned to the cardinal directions with an accuracy that still challenges surveyors, be hiding? Not in terms of treasure, but in terms of purpose? What if the Great Pyramid is not just a tomb, but a surviving shell of a lost function, a machine whose operating manual vanished with the civilization that built it? The Lycurgus Cup and the Delhi Pillar teach us something essential. Objects can be vessels for knowledge that the makers themselves could not fully articulate. And when a workshop tradition dies, the understanding of what an object was for can die with it. We are left with the artifact but not the instruction. The stone remains. The recipe does not. If a small cup and a pillar can hide such secrets, what might a mountain of stone, built with millions of tons of rock and aligned to the stars, be hiding? From the hidden knowledge preserved in a cup and a pillar, we now stand before the largest and most famous ancient structure on Earth. The Great Pyramid of Giza rises from the desert floor on the outskirts of modern Cairo. When it was completed more than 45 centuries ago, it stood 481 feet tall. Its base covers 13 acres. It is made of roughly 2.5 million blocks of limestone and granite, some weighing over 50 tons. The total mass of the pyramid is estimated at 6 million tons. To put that in perspective, the pyramid contains more stone than the Empire State Building, the Chrysler Building, and the Statue of Liberty combined. Imagine building a mountain of stone block by block without cranes or engines, using only human muscle, copper tools, ropes, and ramps. The effort consumed decades of labour, entire seasons of a civilization's energy. The standard story says it was built as a tomb for Pharaoh Khufu, a monument to royal power and the afterlife. Inside, narrow passages lead to a few small chambers. The king's chamber, deep within the pyramid, contains a granite sarcophagus, empty and undecorated. The queen's chamber sits lower and smaller. There are no inscriptions, no treasures, no grand murals. The burial chamber itself is surprisingly modest, a room about 34 feet long, 17 feet wide, and 19 feet high. Compared to the mountain of stone around it, it feels almost like an afterthought. The tomb explanation is not a foolish one. It fits much of the evidence. The pyramid is part of a necropolis. It dates to the Old Kingdom, and nearby texts refer to Khufu's reign. But if it was only a tomb, then the ancient Egyptians poured an astonishing amount of effort into a monument that seems vastly oversized for its stated purpose. And that is where the simple story begins to feel too small. If the pyramid's only job was to house a dead king, why this staggering scale, this precision, this alignment? The base is level to within less than a single inch across the entire 13-acre footprint. The whole structure is oriented to true north with an error of just 1/20th of a single degree. Millions of blocks were shaped and fitted with such care that a knife blade cannot slip between them. A tomb needs no such precision. A tomb does not require sides that align with the cardinal directions with such exactness, or a geometry that encodes mathematical constants. The effort far exceeds the burial function. Something else may be at work here. The question shifts. It is no longer, was it a tomb, but was it only a tomb? And if the pyramid was designed to be something more, perhaps a machine for preserving knowledge, an observatory, a message in stone, then its engineering contains clues that point beyond a simple burial. The pyramid, like the Antikythera mechanism, may be a surviving shell of a lost technical understanding. It echoes the pattern we have traced. A sophisticated object standing alone, the workshops and teachers behind it vanished. In that light, the Great Pyramid becomes more than a burial mound. It becomes an engineering problem that challenges the clean narrative of linear progress. It stands as a monument to a civilization's ability to coordinate, measure, and build with a precision that still puzzles us. And it forces us to ask, what else did they know that we have forgotten? And if the pyramid was designed to do more than house a king, perhaps its internal chambers, its hidden shafts and its mathematical proportions hold the next layer of the mystery. To build something so close to true north is difficult even now. With laser levels, satellite positioning, and a global coordinate system, a modern surveyor still works carefully to shave away error. The Great Pyramid sits on the Giza Plateau with its base aligned to the cardinal points within a fraction of a single degree. 3/60th of a degree, some measurements say. That is not a rough guess. That is a decision made in stone, checked against the sky, and held across more than 230 meters of limestone foundation. But the pyramid does not only know the ground, it knows the stars. Inside the structure, narrow shafts climb from the king's chamber and the queen's chamber toward the northern and southern skies. The southern shaft of the king's chamber pointed in the pyramid's own era toward the constellation Orion. The northern shaft aimed at the star Thuban, which was then the pole star. These are not accidental holes. They are cut through granite and limestone, angled precisely, and they connect the deepest interior of the monument to specific points of light. Someone planned them. Someone understood the slow drift of the heavens well enough to align a stone mountain with a moving sky. What kind of knowledge does that require? Not only astronomy. To set those shafts, the builders had to carry celestial measurements down into a dark, rising structure. They had to translate the dome of the night into angles on a construction site. They had to teach that translation across work crews, seasons, and years. The shafts are not just a calendar. They are a frozen record of a technical chain: observation, calculation, communication, and execution. And behind all of it stands the same shadow that followed the Antikythera mechanism: the missing workshops, the lost teachers, the prototypes that did not survive. The king's chamber itself presses the point further. Its walls are made of enormous granite blocks, brought from Aswan hundreds of kilometres to the south. Granite is hard, heavy, and extremely difficult to work. Yet the blocks are fitted with a precision that still quiets a room. Above the chamber, hidden from any casual visitor, a series of 5 low, relieving chambers stack upward, protecting the space below from the crushing weight of the pyramid's upper mass. The builders knew that weight would try to crack the ceiling. They engineered a solution that remained invisible, uncelebrated, and utterly functional. This is where the story turns. We are not saying the Great Pyramid was a machine in the modern sense, a device that generated power or transmitted signals. We do not need to say that to feel the deeper strangeness. What remains is the possibility that the pyramid's design may encode a purpose we no longer fully read. Imagine finding an object with no manual. You can measure its dimensions, test its materials, and still not grasp what it was built to do. The pyramid's burial chamber is small compared to the whole. Its internal spaces are few. Its shafts point to stars that the old Egyptians associated with resurrection and the king's journey. But even within that religious frame, the sheer scale of the construction, the precision of the alignment, and the hidden engineering above the king's chamber suggest that the monument was not only a tomb. It may have been a message in stone, a structure built to survive the very kind of collapse that erases manuals, languages, and workshops. If a civilization feared losing its knowledge, what would it build? Something vast, something aligned to the permanent sky, something so heavy that it could not be carried away, and so precise that its meaning could be reconstructed by anyone who later learned to measure the earth and the stars. The pyramid begins to look less like a solved puzzle, and more like a surviving shell, the durable outer skin of a technical tradition that, in its full living form, has vanished. Every degree of orientation, every polished granite surface, every silent shaft is a thread that once connected to a larger fabric. The fabric is gone, the threads remain. And now the question shifts again. If stone can preserve alignment, geometry, and a whisper of lost purpose, what about paper? What about ink on old animal skin, copied and recopied across centuries? The next trace is not a monument. It is a fragment of a map that claims to remember something older than itself. In a library in Istanbul, stored away from the noise of the city, lies a fragment of gazelle skin. It is not a complete document. The edges are ragged where the rest of the world has been torn away. The ink is faded, the lines uncertain. And yet this fragile scrap, barely more than a damaged page, carries a quiet claim that has refused to disappear for over 500 years. The fragment is all that remains of a world map drawn in the year 1513 by an Ottoman admiral named Piri Reis. The original map was larger, much larger, but only this piece survived, showing the Atlantic Ocean, the western coast of Africa, the eastern coast of South America, and, at the bottom, a stretch of land that some have argued is the coastline of Antarctica. Now, when a modern person looks at an old map, the first instinct is to compare it to what we know. Does it match the satellite image? Is the coastline accurate? But an old map is not a photograph. It is more like a photocopy of a photocopy of a photocopy. Each time it is reproduced, small details fade, new errors creep in, and the hand of the copyist leaves its own mark. The coastlines shift slightly, the names change, and yet, through all that noise, some original features can persist. An unexpected bay, a river mouth, a peninsula that should not have been known to the mapmaker. Piri Reis himself wrote notes on the map, explaining how he made it. He claimed to have used many older sources, some of them very old indeed. He mentioned maps from the time of Alexander the Great, charts captured from a Spanish sailor who had sailed with Columbus, and other documents whose origins he did not fully explain. In other words, the map was not the product of one man's exploration. It was a compilation, a gathering of inherited knowledge from different times and different hands. The most controversial part of the fragment is that southern coastline. Some researchers have suggested it depicts the edge of Antarctica, and not the familiar ice-covered continent, but a coastline beneath the ice, as it might have looked thousands of years ago. That claim is debated, fiercely debated, and it is not the main point of our investigation. The story I want to follow is not about proving that Piri Reis had access to some secret prehistoric survey. That argument is fragile, and it can distract from something quieter but more important. What matters is the chain itself. The map is a surviving link in a chain of copies. Knowledge was passed down, distorted, reassembled, and sometimes misunderstood. But it was not entirely lost. A coastline remembered by a forgotten sailor ended up in a portolan chart, which was copied by a Greek scribe, which fell into the hands of an Arab geographer, which was captured by a Turkish admiral, who finally drew it onto gazelle skin in Constantinople. The original source may have been destroyed centuries before Piri Reis was born. The people who first recorded that coastline may have left no other trace, but the shape of the land, however altered, survived. This is a different kind of survival than the stone we have been examining. The Great Pyramid stands because its blocks are too heavy to move. The Antikythera mechanism survived because it sank into the protective mud of the seafloor. But a map survives because someone, in each generation, decided it was worth copying. It is a fragile chain of human attention, and it can break at any link. The Piri Reis map does not prove a lost global civilization, but it does something that a single monument cannot do by itself. It shows how geographic memory can travel through fragile media, through paper and ink and animal skin, carrying fragments of a world that no longer exists. It reminds us that knowledge is not always recorded in stone. Sometimes it is whispered from one copy to the next, growing fainter with each retelling but never falling entirely silent. If a map can preserve a fragment of a forgotten world, what about the oldest monuments, the ones aligned to the sky? Did they also carry a memory that outlasted the builders? Perhaps the next traces are not made of paper, but of stone placed with a purpose that only the heavens could read. The map that survives is not whole. It is a torn fragment, a piece of a larger chart, its edges irregular, its surface stained by centuries of handling, moisture, and neglect. Across the animal skin surface, ink lines trace coastlines, rivers, islands, some recognizable, others puzzling. The parchment carries notes in Ottoman Turkish, small annotations that speak of older source maps, of copies made from copies, of a cartographic memory stitched together from many hands. Think of a photograph torn in half. You might lose the background, the context at the edges, but the faces in the centre remain unmistakable. The essential information does not always vanish with the missing piece. In the same way, this damaged map preserves a distorted but recognizable image of the Atlantic world, the Iberian Peninsula, the bulge of West Africa, the eastern coastline of South America. Enough detail persists to argue about what else might have been captured, and those arguments have been fierce. Some researchers have pointed to a southern coastline at the map's lower edge, and argued that it represents the coast of Antarctica, free of ice, suggesting a cartographic memory that predates modern exploration by many thousands of years. Others see that same line as a stretched, misaligned continuation of the South American coast, distorted by the challenges of copying and combining earlier charts. Still others note that the map's interior markings and place names mix real geography with mythological islands and legendary lands. The debate reveals something deeper than a simple yes or no. It shows how difficult it is to read a document that is itself a layered copy, a memory of a memory. The map does not need to be a perfect prehistoric satellite image to be valuable. Its real contribution is the demonstration that knowledge can travel through time in a damaged chain, losing precision, gaining fable, yet still carrying a recognizable core. The Piri Reis fragment is a living record of how information degrades and survives at the same time. That is a lesson that extends far beyond cartography. Here, then, is the turn. We might want a map to be a clean photograph, an unassailable proof. But this map's very ambiguity is its strength. It refuses to be a simple answer. It forces us to confront the messy human process of preserving knowledge. A copyist makes an error. A later scribe corrects it wrong. A coast shifts slightly with each retelling. The past is not a pristine archive. It is a palimpsest, a manuscript scraped and written over, again and again, with only glimpses of the earlier layer surviving. If we demand that every ancient trace be a perfect, transparent window, we will miss the deeper truth, that the fragments are real, but they require patient, careful reading. Now the viewer sees the map for what it is, not a smoking gun, but a testament to the fragility and persistence of memory. The past is a damaged library, and each fragment must be read with care, with an awareness of what might have been lost between the lines. The map's torn edges are not a failure of evidence. They are a reminder that survival itself is a kind of message, and if a map can be a distorted echo of older knowledge, What about the stones that have stood for millennia, aligned to the movements of the sun and stars? Perhaps they too are messages, weathered and partial, their original meanings worn down by time, waiting for a reader willing to see the pattern beneath the erosion. The next trace is not a paper chart. It is a circle of standing stones and a passage tomb that catches the winter solstice light. From the fragile map we turn to monuments that have stood for thousands of years, their stones still catching the first light of the solstice. On the Salisbury Plain in England, a ring of standing stones waits. For most of the year it is a silent circle of grey megaliths, weathered and ancient. But on the morning of the summer solstice, something changes. The sun rises behind the heelstone, a single block standing apart from the main circle. Its first rays shoot straight down the avenue and into the heart of the monument. For a few moments the stone and the star align perfectly. The builders of Stonehenge, some 4,500 years ago, arranged these massive sarsens and smaller bluestones to catch that light on the longest day. They did not write down why. They carved it into the ground itself. In a way, Stonehenge is a calendar made of stone. But the idea was not unique to one island or one people. At Newgrange in Ireland, a passage tomb built more than 5,000 years ago, the winter solstice sunrise sends a narrow beam of light deep into the central chamber. For about 17 minutes, the darkness inside is broken by a shaft of gold. The builders constructed the roof box precisely to admit that light on the shortest day. Again, stone and sun meet at a moment that repeats every year. These are not the only examples. Across the world, from the temples of Malta to the pyramids of Egypt, ancient builders aligned their most durable structures with the movements of the sun, moon, and stars. We are not claiming a single global network or a lost worldwide school of architects. The pattern is more interesting than that. It is a repeated human impulse. Different cultures, separated by oceans and centuries, kept arriving at the same solution: erect stone in dialogue with the sky. The question moves from what they did to why. Why invest so much labour in aligning stone with the heavens? Moving stones of several tons across miles of land, shaping them, raising them upright. Every step cost food, time, and lives. A society does not pay that price for a simple calendar. The seasons were visible in the behaviour of plants and animals. They did not need a stone ring to know when to plant. So the alignment must have held a deeper purpose. Perhaps it was about connecting the human world to the cosmic order. Perhaps it was about preserving knowledge that could not be entrusted to memory alone. The sky's a clock that never stops, a pattern that repeats even when civilizations collapse. If you encode your most important observations into stone and align them with the sun's eternal return, the message outlasts any language. In this way, the sky became a language, not a spoken language, but a mathematical and visual one, written in light and shadow. The Antikythera mechanism, that corroded bronze computer we began with, was a portable translator of that language. The Great Pyramid, with its precise cardinal orientation, was a sentence written in stone. The sky monuments are the oldest pages of a book that still opens once a year, and if the sky was a language, then the question that follows is harder to ignore. What kind of catastrophe could make such a durable message necessary? What were they trying to tell the future? What if the sky itself was the first universal language? The Antikythera mechanism compressed the heavens into a bronze box. The Great Pyramid locked its passageways onto a single point of northern light. And in the green hills of Ireland, a passage tomb called Newgrange was built so that, for a few minutes each winter solstice, a shaft of sunlight would slide through a roof box and illuminate the inner chamber. At Stonehenge, the largest stones frame the midsummer sunrise and the midwinter sunset with an accuracy that still works more than 4,000 years later. Taken separately, each site points to the sky. Taken together, they begin to look like different devices running the same operating system. That operating system was written in the movements of the sun, the moon, and the stars. It was predictable in ways that no human ruler could match. It did not require a shared language, a shared empire, or a shared religion. A solstice in Ireland and a solstice in Egypt were the same event, separated only by the angle of the horizon. The sky offered a reference that was older than any writing system, older than any city, and visible to anyone who looked up. It is tempting to imagine a single ancient school teaching all these builders the same code, but the physical evidence does not demand that. What it does demand is something more subtle, a shared response to the same sky. Different cultures, separated by oceans and centuries, found the same solution to the same problem. The sky was there, it was regular, it was eternal, and so they carved stone to match it. Now, why would anyone spend such enormous effort to align stone with a light? One answer is practical: to track the seasons, to know when to plant and when to harvest. But that explanation only goes so far. A simple wooden post can mark a solstice. A stone circle that weighs hundreds of tons is something else entirely. It is not just a calendar, it is a statement. It is a message written in the most durable material available, aimed at the most durable cycles the builders knew. If you wanted to send a message across time, you would not write it on paper. Paper burns. You would not carve it into wood. Wood rots. You would not trust it to language because languages die. You would choose stone, and you would align that stone with something that repeats forever. The rising sun on the longest day, the setting sun on the shortest, the star that circles the north without ever dipping below the horizon. This is what the pyramid, the passage tomb, and the stone circle have in common. They are not merely monuments, they are durable memory. They are attempts to make sure that something would survive. What that something was, we can only guess. A warning, a calendar, a sacred instruction, a memory of a world that had already been lost. The objects themselves do not tell us the full story. But the pattern is hard to ignore. It appears in Egypt, in Ireland, in England, in the Andes, in India, and in dozens of other places where ancient people looked at the sky, and then looked at the ground and decided to build something that would outlast them. The viewer now carries a new possibility, that these monuments are not separate curiosities, but fragments of a much older human effort to speak across deep time. They are survivors of a conversation that began before writing, before cities, and perhaps before the last great catastrophe. And that is the next question. If these messages were built to survive something, what was that something? What kind of event could erase the fragile parts of a civilization while leaving only the stone, the metal, and the myths? The next trace is not a monument. It is a landscape reshaped by fire and water. We have followed objects and monuments. Now we step back to see the landscape that shaped their survival, a world that changed faster than any written record. Around 12,800 years ago, as the last ice age was losing its grip, something pushed the planet back into the cold. Temperatures plummeted, ice sheets that had been shrinking suddenly advanced again. The drop was abrupt and severe. This cold snap, known as the Younger Dryas, lasted more than 1,000 years, and when it ended, the warming returned with a violence that reshaped the Earth. At the peak of the Ice Age, so much water was locked in ice that sea level sat roughly 120 meters lower than today. Vast stretches of what is now seabed were dry land. Coastal plains, river deltas, freshwater lakes near the shore, places where people naturally gather. Then the ice melted, not slowly everywhere, but in pulses. Imagine a bathtub filling. A slow rise is manageable, but when a large block of ice calves and water rushes in, the level jumps. For the people living on those low coasts, the sea did not creep. It swallowed. The numbers are staggering. Around 25 million square kilometers of habitable land disappeared beneath the waves, an area larger than the entire continent of North America. The Persian Gulf was once a fertile valley. The Black Sea was a freshwater lake with shorelines far below the present surface. The Sunderland Shelf in Southeast Asia connected islands into a vast subcontinent. Doggerland, between Britain and Europe, was a rich lowland of marshes and rivers. All of them are gone now. The people who lived there left no stone cities for us to find, only scattered tools brought up in fishing nets. This matters for every object we have examined. The Antikythera mechanism survived because it sank in a shipwreck and was buried in sediment. Puma Punku and Barabar sit on high ground. The Great Pyramid stands on a desert plateau. These are the survivors of a biased archive. We are not seeing the whole record of ancient human accomplishment. We are seeing the parts that were built on stone, in arid zones, or accidentally preserved by catastrophe. The coastal workshops, the timber prototypes, the oral traditions, they vanished. To be clear, this is not proof of a lost global civilization. It is a reason the surviving evidence is so thin, and why objects like the mechanism feel so isolated. Absence of evidence is not evidence of absence. It is evidence that the library burned, and only a few pages drifted down to us. Now the past begins to look different. Not a complete picture, but a damaged one. And every fragment we do have, the bronze gears, the polished granite, the colour-changing glass, becomes more precious, not less. They are not outliers. They are the few voices that manage to speak across a drowned world. And if the coastline's drowned, what about the places that remained above water? The next site was buried on a hilltop, older than it should be, waiting to be uncovered. From the drowned coastlines and the silent traces of a flooded world, we turn inland to a hill in southeastern Turkey. A hill that, for thousands of years, looked like nothing more than a gentle rise in the dry Anatolian landscape. But beneath the surface, it held a secret that would force archaeology to rewrite the first chapters of civilization. In the 1990s, a German archaeologist named Klaus Schmidt began to dig. What he uncovered was not a village, not a burial mound, but a complex of massive T-shaped limestone pillars arranged in circles. The pillars were carved with animals: foxes, snakes, birds, scorpions, wild boars. Some pillars stood over 5 meters tall and weighed up to 20 tons. The site was named Göbekli Tepe, and it dated to around 9600 BC. That date changes everything. This was built before pottery, before farming, before the first cities. It was erected by hunter-gatherers, people who had not yet settled into permanent villages. In the simple story of human progress, monuments come after agriculture, after surplus, after social hierarchy. Göbekli Tepe stands before all of that. The site does not prove a lost global civilization. It does not show advanced machinery or forgotten high technology. What it does prove is that the human impulse to build monumental sacred spaces, to carve stone with symbols and arrange it according to cosmic or ritual logic, emerged far earlier than the old model allowed. It is a real, excavated, carefully documented archaeological site, and its existence complicates the linear ladder of development. We are not using Göbekli Tepe as a secret key to a hidden empire. Instead, it serves as a geological layer in our investigation. It shows that the sequence is not a straight line, and that fits the pattern we have been tracing. Skills and knowledge can appear, flourish, and then fade, leaving only stone behind. The lost technical traditions we have followed, from the Antikythera mechanism to the precision stonework of Puma Punku, gain a deeper context when we see that monument building itself has an older, more complex story. So what drove hunter-gatherers to cut, transport, and erect pillars weighing many tons? Every day spent quarrying and carving was a day not spent hunting, gathering, or securing immediate survival. Something made that cost worth paying. It was not a king's command, not a tax surplus, not a written decree. Perhaps it was a shared belief so powerful that it could organize labor across bands, a vision of the cosmos that needed to be anchored in stone. The site is not a city. It may have been a gathering place, a ritual center where people came together for ceremonies, feasting, and memory. The effort itself became a kind of technology, a social technology of cooperation and meaning-making that preceded the state. Göbekli Tepe does not answer all our questions, but it removes the comfort of a simple ladder. It suggests that the human story has always been more complex, with periods of intense symbolic and technical creativity that may not leave a continuous record. And if such a monumental tradition could arise so early, and then be deliberately buried and forgotten, how many other chapters lie hidden beneath the soil, underwater, or erased by time? And now, with this final piece, we can look back at the whole chain. The machine from the sea, the engineered stones of Puma Punku, the polished chambers of Barabar, the colour-changing glass, the rust-resistant iron pillar, the pyramid that refuses to be small, the map that copied older maps, and the sky monuments that still track the seasons. What do these traces become when we see them together? We have travelled from a corroded bronze machine fished out of the sea to a hilltop sanctuary that was already ancient when the first cities rose. Now let us gather these fragments and see what they become. A mechanism of interlocking gears that modelled the heavens, precision-cut stone blocks on a Bolivian plain, shaped like components for a machine we no longer remember. A granite cave in India polished until the walls reflect a whisper, and the darkness feels deliberate. A Roman glass cup that shifts from green to red when light passes through it. An iron pillar standing in Delhi that has barely rusted across 16 centuries of monsoons. A pyramid of staggering mass oriented to the stars with an accuracy that still raises questions. A map drawn in Constantinople that claims to have copied older maps now lost to time, stone circles in England and passage tombs in Ireland that catch the solstice sun as if the builders wanted to lock the calendar into the landscape, and a hill in Turkey where people raised carved pillars before farming, before pottery, before the old story said such things were possible. These objects do not belong to the same culture. They are not pieces of a single puzzle. They are pieces from different puzzles, scattered across continents and millennia, each one a survivor of a different vanished world. But when you lay them side by side, a shape begins to emerge, not a single lost civilization. Something quieter and perhaps more unsettling. A pattern of knowledge appearing, flourishing, and then breaking. Look at them not as treasures, but as categories. Mechanical knowledge, the Antikythera mechanism. Stoneworking knowledge, Puma Punku and Barabar. Material knowledge, the Lycurgus Cup and the Delhi Pillar. Architectural and astronomical knowledge, the Great Pyramid, Stonehenge, Newgrange. Geographic memory preserved through copies, the Piri Reis map. And the social knowledge required to organize labour before the state, Göbekli Tepe. Each object represents a different kind of expertise, a different chain of hands and minds that once transmitted a skill from teacher to student, from one generation to the next, and in each case that chain snapped. The workshops vanished, the recipes were forgotten, the maps were lost, the instructions died. What remains are the objects. The heavy, durable shells of knowledge that outlasted the fragile systems that created them. This is not a story about ancient people possessing modern science. It is a story about how easily specialized knowledge can disappear. A workshop that knows exactly how to mix gold and silver into glass, or how to forge iron that resists corrosion, or how to cut and polish granite to a mirror finish, is not a permanent thing. It is a living tradition. If that tradition stops, the knowledge does not leave a manual behind. It leaves only the finished objects mute and mysterious. And so the question shifts. It is no longer, did ancient people have advanced technology? The sharper question is, how many times did chains of knowledge break? And what was lost each time? We're used to thinking of history as accumulation, but the objects we have followed suggest something different. They suggest that the past is more like a landscape of rises and falls, of bright periods of skill followed by long silences. The Antikythera mechanism was not the first computer. It was the last surviving echo of a mechanical tradition that had already begun to fade by the time that ship went down. The precision at Puma Punku and Barabar may represent the peak of stoneworking knowledge that later generations could not replicate. The pyramid at Giza may be the loudest surviving statement of an architectural language whose other sentences are buried or broken. If this pattern holds, then our own world is not immune. Our knowledge, too, lives in chains, in books, in institutions, in the memories of specialists, in digital archives that require electricity and working devices to read. If those chains break, what would remain of us? The heavy things, the concrete shells of power plants, the rusting steel of bridges, the silent dishes of observatories pointed at a sky no one interprets anymore. Perhaps a few strange objects, corroded and puzzling, that a future finder would try to understand. And that is where we turn next. If the past is a story of broken chains, what would the future find of us? Imagine, for a moment, a world where our own knowledge has vanished. The corroded bronze gears from the shipwreck near Antikythera did not arrive alone in the museum. They arrived as a survivor, a single machine pulled from the sea, surrounded by a silence where its teachers, its tools, and its successors should have been. That silence is the real story. Think of technical knowledge not as a ladder, but as a rope. Many thin strands wound together, the hand that teaches, the drawing that explains, the failed prototype that teaches the next, the language that names the parts. Cut the rope, and the heavy links survive. Bronze, stone, iron, glass. The light, fragile links, the instructions, the memory, the living chain of hands dissolve. Now pull back. Look at the objects we have carried through this journey, not as separate wonders, but as functions in a broken system. A machine that calculated the sky. The Antikythera mechanism, with its interlocking gears and its missing workshops. Stone shaped like components. The andesite blocks at Puma Punku, with their repeated sockets and sharp angles, pointing to a lost tradition of shaping hard stone with a purpose we only partly understand. Chambers polished until the walls reflect sound and silence. The Barabar caves, where the finish was not just a surface, but a technology of the senses. Glass that changes colour when light passes through it. The Lycurgus Cup, a recipe for nanoparticles preserved in Roman glass long before the theory existed. Iron that resists decay through a protective layer formed by the very hands that forged it. The Delhi pillar, standing as a memory of a metallurgical tradition that knew what worked without needing to name the chemistry. A pyramid aligned to the stars with extraordinary precision. Giza, not just a tomb, but a mountain of coordination, a structure that may encode more than a burial because the builders spent enormous effort on alignment and scale. A map that says it copied older maps, the Piri Reis fragment, a palimpsest of inherited geography where coastlines and legends mingle, and knowledge travelled through copies of copies, distorted but not entirely erased. And monuments built to catch the solstice light, to mark a moment that returns every year, as if the builders were trying to write a message in a language that outlasts words. Stonehenge, Newgrange, and others, where stone and sky become a durable memory. Each of these is a function: calculation, shaping, recipe, alignment, preservation, copying, survival. They are not evidence of a single lost global empire. That claim is larger than the facts can carry. But together, they reveal something more subtle and more unsettling. A recurring pattern of broken transmission. Specialized knowledge that appeared, reached a height, and then vanished when the chain of hands was cut. The object remains, the instruction dies. This is not a mystery that can be solved with a single answer. It is a condition of civilization itself. Knowledge is fragile. It lives in the spaces between people, and when those people disappear, the knowledge disappears with them, leaving only the heaviest shells. And that thought turns the question forward. If these ancient fragments are the surviving shells of broken chains, what would remain of our own civilization if our chain broke? What would a future archaeologist find 2,000 years from now, when our digital memories have decayed, our books have crumbled, and only the heaviest structures survive? Let us imagine that future. A world where our own knowledge has vanished and only fragments remain. From the synthesis of broken chains, we now step into a future where our own chain has broken. Imagine a dig site centuries from now, a new intelligent species, or a recovering humanity stripped of its old memory scrapes away soil and finds concrete. Not a single block, but a vast smooth wall curving into the earth. There are no doors, no windows, no inscriptions. The wall simply rises and then stops, as if it once held back something immense that is no longer there. The excavators measure it, map it, and argue. One faction believes it was a ritual boundary, a sacred line between worlds. Another insists it was a container for a vanished lake. Nobody guesses that it was a dam because the river it restrained dried up long before the first shovel touched the ground. The purpose is gone, and only the shell remains. That is how knowledge disappears. Not because people are foolish, but because the context that gives an object its meaning is far more fragile than the object itself. Think of the smartphone in your pocket. Right now it is a window to almost everything: maps, voices, libraries, faces, the accumulated record of a life. But take away the network, the power grid, the software updates, and the factories that replace its parts, and wait a few centuries. It becomes a smooth black rectangle, a polished slab of glass and metal with no readable data. A future archaeologist might hold it up to the light and see only a dark mirror. They might call it a ceremonial plaque, a status token, or a decorative tile. They would never know that it once carried the voices of people who loved each other across oceans. Now extend that thought. Our world is full of objects that will outlast their explanations. A highway overpass stripped of its cars and its traffic becomes a strange elevated path that leads from nowhere to nowhere. An ancient causeway whose ritual purpose scholars will debate for generations. A wind turbine, its blades frozen and its generator silent, stands on a hill like a skeletal giant, a monument to a forgotten sky religion. A server farm, row upon row of corroded metal boxes in a windowless hall, becomes a tomb of useless artifacts whose original function is completely opaque. The future diggers will find these things and weave stories around them. They will not be stupid stories. They will be careful, evidence-based, and utterly wrong, because the fragile layer of knowledge that once made everything connect has evaporated like water on a hot stone. And this is where the old machine from the sea comes back to us. The Antikythera mechanism we have been carrying through this journey, that corroded bronze assembly of gears and dials, is exactly such an object. It is a hard drive from a vanished operating system. The people who made it knew the sky, knew metal, knew ratios, knew how to teach these things from one hand to the next. But the workshops are gone. The manuals are gone. The chain of transmission is broken, and we are left holding a single, astonishing fragment, turning it over in our hands, guessing at its full meaning. A future archaeologist would hold one of our hard drives the same way. A polished disc, a mysterious arrangement of materials, a thing that clearly meant something immense and is now silent. The sudden shift is this. We are no longer only the ones asking the questions. We are the answer that will be found, incomplete and silent. Our cities, our knowledge, our certainties, they will all become the ancient mystery for someone who comes after. The monuments we build to last, the data we trust to be permanent, will one day be rubble and unreadable code. And the few objects that survive the collapse will be treated exactly as we treat the Antikythera mechanism, with wonder, with respect, and with a deep, unresolvable confusion about what they were truly for. So the ancient anomalies we have been examining are not just curiosities from a distant past. They are a mirror. They show us what we will become. Every broken chain of knowledge we uncover in the ancient world is a preview of our own fragility. The past is not a closed case. It is a warning written in stone, in bronze, in glass. A warning that says, everything you think is permanent can be forgotten, and the objects that remain will tell a story you never intended. And so we return to that first machine, the one that started this journey, and see it with new eyes. In a museum case, under soft light, the Antikythera mechanism rests in fragments. Greenish bronze eaten by salt and time, a few thin plates, the ghosts of inscriptions, and between the corrosion, the teeth of tiny gears, some no larger than a fingernail. It is hard to look at it now and see an engine. It looks more like a broken thought, a sentence the sea forgot to finish. But once, in a workshop that no longer exists, hands shaped these gears, hands that understood the sky, hands that knew metal and ratio and the slow dance of the moon. The machine has not changed. The world around it has. At the start of this journey it was an anomaly, a single impossible object that made the simple ladder of progress feel wrong. How could something so precise come from an age that was not supposed to build such things? Then it became something else, a sign that workshops could vanish, that whole traditions of knowledge could disappear while one survivor lay buried in sand and salt. It became a warning. We cannot recover the missing workshops. We cannot ask the builders what they knew, the teachers, the failed prototypes, the manuals drawn on wax or papyrus. They are gone, but the mechanism remains. And now, after all the stone and glass and iron, after the pyramid and the map and the silent chambers, this small bronze machine has grown larger than its size. It is not just an ancient computer. It is a message from a world that lost almost everything except this one fragile shell. If one broken machine, pulled from a shipwreck, could change how we read the past, then what small overlooked object from our own time might someday rewrite the future's idea of us? Maybe a hard drive no one can read, a concrete shell without its manual, a quiet observatory with its instruments still pointed at stars whose names have been forgotten. The gears are still now. The sea has given up its secret. But the question it carries will outlast any single answer. And somewhere, under another sea, or buried in another desert, or resting in a museum case not yet built, another fragment is waiting for someone to find it and ask the right question. From the corroded gears of the Antikythera mechanism, we turn now to another silent survivor. The Great Pyramid stands at Giza, its limestone casing mostly stripped away, its inner chambers empty of the king's body they were meant to guard. For over 4,000 years it has watched empires rise and fall, languages vanish, and the desert slowly shift around it. The builders who cut the stone and hauled it into place could not have known what it would become. Knowledge passes from hand to hand like a candle flame. One gust of wind and the flame goes out. The wax and the wick remain, but the light is gone. The pyramid is the wax and the wick, a massive container built to hold something that its makers considered essential. But the flame itself, the living understanding of why every stone was placed exactly so, what the shafts pointed toward, what the empty granite box truly meant to them. That flame flickered and died long before any modern archaeologist walked through the descending passage. We are left with the container, and we fill it with our own light. Over the centuries, the pyramid has been read in radically different ways. To the ancient Greeks, it was the tomb of a tyrannical king. Roman travellers saw it as a granary built by the biblical Joseph. Medieval Arab scholars imagined it as a treasury of hidden knowledge, its passages sealed against intruders. Astronomers in the 19th century measured its alignments and found celestial codes. More recently, some have proposed it was a power plant, a resonance chamber, or a machine for transforming consciousness. The pyramid does not correct any of them. It does not speak. It simply endures, accepting every new story that humans project onto its silent stone. In this sense, the pyramid is already a future ruin from the perspective of its builders. They intended something. They spent lifetimes on something. But the meaning they placed inside those chambers is separated from the physical object, drifting down the centuries until it became unreachable. We can measure the stone with lasers, map the shafts with robots, and count the blocks with satellite imagery, but we can never recover what it felt like to stand at Giza when the casing stones still gleamed white, and the entire structure was a single, coherent act of faith. And now we must turn that question on ourselves. What messages are we building today that will be misread by those who come after? Our largest structures, the dams that hold back rivers, the radio telescopes that listen to deep space, the server farms humming with the entire digital memory of our age, will one day be silent. Future minds will walk among their ruins and tell stories about them that we cannot imagine. They may decide our data centers were temples, that our particle accelerators were monuments to forgotten gods, that the concrete shells of our reactors were tombs for a lost priesthood. Would they be wrong? They would be doing exactly what we do when we stand before the pyramid. The act of building for permanence is always an act of faith in a future that will not understand us fully. That is not a failure. It is a property of deep time. The gap between the builder and the interpreter is unbridgeable, and the mystery we feel before ancient stones is not a puzzle to be solved. It is the natural consequence of time erasing the soft parts while leaving the hard parts behind. The pyramid stands because it is heavy and strong, not because it is clear. The meaning was always the most fragile part. And if stone can be so easily misread, what happens when knowledge is passed not through monuments, but through copies of copies, like a map? The Piri Reis map shows how knowledge can distort even as it endures, travelling across centuries in fragments, each new hand adding its own understanding until the original is almost unrecognisable. The parchment is yellowed now, fragile as dried leaf. The handwriting belongs to the Ottoman Admiral Piri Reis, and the date is the year 1513. But the coastline drawn on this fragment does not quite match the shorelines we know. It curves and bends in ways that feel half-remembered, as if someone copied a much older drawing and quietly changed a detail each time. Think of a game of telephone, the kind where a sentence passes from one person to the next in a circle. By the time it reaches the last ear, the words have shifted. A name becomes a number, a direction becomes a guess. But sometimes, buried inside the distortion, the original shape is still there. A coastline, a river mouth, a chain of islands. The map is like that final whisper, a memory of a memory carrying both truth and noise. The Piri Reis map itself is not a hoax. The Admiral wrote on its face that he had used older sources, some of them captured from a Spanish sailor who sailed with Columbus, some of them perhaps drawn from ancient charts held in imperial libraries. The map blends real geography with places that feel more like legend. That blending is not deceit. It is the natural result of copying across language, across time, across a world that kept losing its own records. Every ancient text we have, every inscription, every map is a copy of a memory. The originals are almost always lost. What we hold is a damaged library, a collection of fragments that survived fire, flood, war, and the slow rot of organic material. The map is not a lie. It is a palimpsest, a document written and overwritten, where the older layer shows through in faint traces that no longer fit the surface. And now, sitting in a clean modern room, we can look at a phone screen and see the whole earth turning. Every road, every river, every street corner. It feels permanent. It feels as if nothing could erase it. But think of that hard drive in 100 years, 1,000 years, when the power is gone and the software that reads it no longer exists. A future archaeologist finding a polished disk might hold it up to the light and see only a mirror. No words, no coastlines, no map, just a strange, smooth object that does nothing. The digital world is the most fragile medium we have ever built. It does not decay into partial truth. It vanishes completely when the last machine that can read it stops working. A papyrus map, even burned at the edges, still speaks. A stone inscription, even weathered, still holds a shape. But a solid-state drive without a working reader becomes a silent black box. Our own records, so vast and so confident, may one day be less readable than the oldest clay tablet ever pulled from the ground. The Piri Reis map, for all its distortions, is still here. It sits in a museum in Istanbul, and you can look at the ink lines and the careful script and the ghost of a coastline that might be South America or might be something else, and you can feel the chain of hands that passed it forward. The uncertainty we feel about ancient objects is not a failure of intelligence. It is the signature of a medium that was never meant to be perfect. The mystery is in the transmission itself. Every copy is both a preservation and a betrayal, so the map becomes a quiet symbol. It reminds us that we do not see the ancient world directly. We see it through a broken chain of retelling, through stone that was moved and recarved, through metal that was melted down and recast, through words that were translated by people who no longer spoke the old language. And that imperfection is not an obstacle to knowledge. It is the very reason mystery exists. If the record were complete, there would be nothing left to ask. But some builders chose a different medium. Not paper, not ink, not even stone alone. They looked up, saw the sky repeat itself, and began to write their memory in the one language that outlasts language. The slow, eternal rhythm of the sun and stars. And that is where the story turns next. From the Piri Reis map's fragile paper, we turn to the most durable page of all, the sky. On the morning of the summer solstice, the sun rises behind the heel stone at Stonehenge and sends a shaft of light directly through the centre of the circle. 5,000 miles away, inside a grassy mound in Ireland, the winter solstice sun crawls along a narrow passage and ignites the back wall of Newgrange. These are not random openings. They are alignments cut into stone with a precision that still works 4,000 years later. Think of them as clocks that need no battery, no instructions. They reset themselves every year, as long as the sun continues to rise. Unlike the copied and recopied maps of later eras, these sky marks are self-correcting. The sun arrives on time and the stone confirms it. The builders left no written explanation, but the stones suggest an intent, to anchor human time to cosmic time, to create a marker that would outlast all memory. Empires fall, languages die. But the solstice returns. It is a message that reads itself. The same sky that the bronze gears of the Antikythera mechanism modelled was the sky these stones were built to greet. One captured the heavens in moving metal. The other captured it in position. Both were attempts to write cosmic order into physical form, to make sure that something would remember. So why did so many cultures invest so much in aligning stone with the heavens? Perhaps because they understood fragility. They knew that stories vanish, that cities burn, that whole peoples can disappear. But if you align a stone with the sunrise on the longest day, the stone will still be there, and the sun will still rise. It is a quiet act of defiance against oblivion. We were here. We knew the sky. Remember. We build our sky monuments too. Satellites orbit above us. Telescopes scan distant galaxies. Atomic clocks tick with unimaginable precision. They are the cathedrals of our own era, pointing toward the cosmos. But they depend on power, data networks, and a civilization that knows how to read their signals. When that civilization falters, they fall silent. A future archaeologist might find a dead satellite and see only a strange metal shape, not a timekeeper. Our monuments to the sky will become mute. The ancient builders understood something we have forgotten. The most durable message is one that does not depend on any single civilization to interpret it. The sun and stars are the universal translators. A solstice alignment speaks to anyone who watches the sky, whether they live now or 10,000 years from now. And perhaps that urgency, to build something that would outlast the builders, was born from a catastrophe that nearly erased everything. Imagine the world at the end of the last ice age. Ice sheets that had held enough water to lower the oceans by more than 100 meters were melting. The sea rose, slowly, then in pulses, swallowing the coastal plains where generations had fished, traded, and built their homes. During the Younger Dryas, a sudden cold reversal disrupted the climate, but the long thaw continued. By the time the sea stabilized, the shorelines had moved inland by dozens, sometimes hundreds of kilometers. The edge of the human world had drowned. If human history were a library, the rising water would have washed away all the books on the lower shelves. We can only read the ones that were kept on the top, the stone monuments, the desert settlements, the caves. Beneath the North Sea lies Doggerland, a lost world of marshes, rivers and low hills that once connected Britain to mainland Europe. Fishermen sometimes dredge up bones and tools from that drowned landscape. Off the coast of India, sonar surveys have revealed ancient river channels and possible settlement sites now under tens of meters of water. In the Mediterranean, the coastal plains that once stretched far beyond today's beaches are gone, their harbours and villages buried under sediment. These were not empty margins. The coasts were where the richest resources were: shellfish, fish, migratory birds, fertile estuaries. They were likely the most densely populated zones of the prehistoric world, and in our own future, the same process will occur. The cities we think are permanent, New York, London, Shanghai, will one day be underwater, their steel and glass crumbling into sediment. Only the highest structures might protrude like lonely concrete reefs. So the ancient survivors we have traced, the bronze gears, the shaped stones, the polished chambers, are not anomalies. They are the lucky few that escape the general erasure. The mystery is not why there are so few traces, but why any survived at all. The question now shifts. It is not, did a lost civilization exist, but how much of the human story is permanently lost and what do the remaining fragments tell us about the whole? The reset landscape is not an excuse for fantasy, it is a call for humility. And so, after this long journey, we gather all the fragments and see what picture they form, incomplete as it is. Look at them one more time, not as isolated curiosities but as a constellation. There is the corroded bronze machine from the sea, its gear teeth still holding the rhythm of the heavens. The shattered andesite blocks of Puma Punku, cut and socketed like components of a device no one can name. The polished granite chambers of Barabar, where sound and silence meet a surface so smooth it seems to swallow the light. The Roman glass cup that shifts from green to blood red when light passes through it, a trick of nanoparticles 2,000 years before the word existed. The iron pillar in Delhi, standing in the open air century after century, its secret locked in a protective layer that modern instruments can only partly explain. The Great Pyramid, an impossible mountain of stone aligned to the stars with a precision that still challenges engineers. A fragment of a 16th century map, its parchment carrying coastlines and rumours from sources that no longer survive. The stone circles and passage tombs built to catch a single ray of solstice sun year after year, like a clock that ticks once every 12 months. And the drowned landscapes, the submerged coastlines, the silent continental shelves where the first chapters of human civilization may lie buried under meters of water and sediment. Think of them as stars. A single star tells you nothing about the shape of the night sky. But connect them, and they become a constellation, a story written in light. The bronze gears of Antikythera speak of calculation, a machine that compressed the sky into a box. Puma Punku speaks of shaping, stone worked with an almost industrial precision. Barabar speaks of finish, a desire to perfect not just the form but the very surface of the rock, perhaps to alter experience itself. The Lycurgus Cup speaks of material knowledge, a recipe that produced an effect we still struggle to replicate casually. The Delhi pillar speaks of preservation, an understanding of metal chemistry that resisted decay for over 1,000 years. The Great Pyramid speaks of alignment and mass, a structure so precisely oriented and so vast that it forces us to ask what else it might have been designed to do. The Piri Reis map speaks of copying, a fragile chain of parchment and ink that carried geographic memory across centuries, distorting it but never fully erasing it. The sky monuments speak of cosmic order, a shared human impulse to anchor our fleeting lives to the eternal cycles of the heavens. And the drowned landscapes speak of loss, the quiet, relentless erasure of entire worlds by rising seas and shifting climates. None of these objects, on its own, can prove a single lost global civilization. That is not the pattern. The pattern is simpler and more haunting. Across time and across cultures, human beings have repeatedly poured their best knowledge into durable forms, hoping to cheat decay. And repeatedly the chain of transmission has broken. The instruction dies, the object remains, and now we are the ones holding the chain. Our knowledge is no more permanent than theirs was. Our digital records are more fragile than stone. Our machines will rust. Our languages will shift. Someday someone will dig through our ruins and try to understand what we knew. History is not a straight line of progress. It is a chain of hands passing knowledge from one generation to the next. The ancient objects we have visited are not just mysteries to solve. They are warnings. They are inspirations. They are the surviving links in a chain that we now hold. The question is, what kind of link will we be? And so we come to the final thought. What does it mean to be a good ancestor to the future archaeologists who will one day dig through our ruins? What do we want the future to know about us? It is a question every civilization answers, whether it means to or not. The ancient builders who carved Puma Punku, who polished the granite chambers of Barabar, who aligned the Great Pyramid to the stars, they were not only building for their own time, they were placing messages into deep time, hoping that someone someday would find them and understand. Think of it as a time capsule, not a box buried in a schoolyard, but a deliberate choice of what to preserve and what to let go. We do the same thing today. We have sent the Voyager Golden Record beyond the solar system, a gold-plated disc carrying the sounds of rain and wind, a mother's first words to her child, a Beethoven quartet, and greetings in 55 languages. It will drift for billions of years, long after the Earth is gone. It is our own sky monument, our own Antikythera mechanism, encoding who we were for any eye that might find it. We have built the Svalbard Global Seed Vault, buried deep inside a frozen mountain in the Arctic, containing millions of seed samples from every crop on the planet. It is a backup of the world's agricultural memory, a silent promise that even if our fields burn or our cities fall, the knowledge of food can be reborn. And we have designed warning markers at nuclear waste sites, immense stone pillars, pictograms of screaming faces, messages in multiple languages, all trying to say one thing across 10,000 years. Do not dig here. This place is not a tomb. This place is a wound. These are extraordinary efforts. They show that we, like the ancient builders, understand the fragility of our own memory, but they also reveal a deeper fragility. The Voyager Golden Record requires a machine to play it. The stylus, the turntable, the knowledge of how to spin the disc at the right speed, all of that is assumed. The Seed Vault requires a functioning society to retrieve the seeds, to know when to plant them, to have soil and water and hands that remember the old rhythms. The warning markers require a reader who still understands the symbol for danger, who can read a language that may no longer exist, who can interpret a pictogram across 10 millennia of cultural change. A time capsule is only as strong as the chain of transmission that carries it, and that is the quiet turn. The most durable message is not a single object, no matter how well made. It is a living tradition of teaching and learning. The ancient builders did not simply leave behind stones. They left behind the hands that shaped the stones, the master who showed the apprentice how to hold the chisel, how to read the grain, how to polish until the surface sang. That chain of hand to hand, voice to ear, generation to generation. That is the real message. It is still being sent. Every time a teacher shows a student how to read an ancient text, how to mix a pigment, how to calculate a gear ratio, the chain continues. The Antikythera mechanism was not built to be found. It was built to be used, to teach, to demonstrate the order of the heavens. And yet it survived. It survived the shipwreck, the corrosion, the centuries of silence on the seafloor. It survived because it was made of bronze, because it sank in just the right place, because a sponge diver happened to notice it, because generations of scientists refused to stop asking what it was. The mechanism itself is not the whole story. The story is the unbroken human curiosity that carried it from the hands of an ancient Greek artisan to the hands of a modern researcher. And so we end where we began, with a small bronze machine. But now we see it differently. It is not a puzzle to be solved. It is a gift passed forward through time, a reminder that we are part of an unbroken chain of human wonder, stretching back to the first hand that shaped a stone, and forward to the last hand that will ever hold one. The question is not only what the ancients wanted us to know, the question is what we, in our turn, will choose to send forward. The corroded bronze sits behind glass now. Green patina covers the surface. The edges of the broken gears catch the light from the museum lamps, and for a moment you can see the tiny teeth that turned against each other 2,000 years ago. It does not move anymore. It does not need to. The Antikythera mechanism is not a puzzle that asks to be solved. It is a letter written in bronze and gearwork sent across the sea in the centuries. The message is simple, and it says this: we knew the sky. We built machines. We tried to understand. We hope you do too. Think of the hands that made it. Hands that knew the stars, that cut bronze, that calibrated gear ratios, that tested and failed and adjusted. Hands that passed that knowledge to an apprentice, who passed it to another, until one day the chain broke. The workshop fell silent. The tools were lost. The last person who understood the full craft died, and the knowledge died with them. But the object survived. It sank in a shipwreck and waited in the dark. Then a diver found it. Then scientists decoded it, piece by corroded piece, and now it sits here, in the light, speaking silently to anyone who will listen. We cannot repair the chain. We cannot bring back the workshops or the teachers or the failed prototypes. But we can read the message that survived. We were here. We wondered. We built. That message changes something in the reader. It says that curiosity is ancient, that the drive to understand the sky, to compress the heavens into a box of gears, is not a modern invention. It is a fragile flame that has been passed from hand to hand for a very long time, and now it is our turn. What will we build that will say the same to those who come after? What single object, if everything else were lost, would tell the future that we too looked up at the stars and tried to make sense of what we saw? The Antikythera mechanism does not answer that question. It only sits there, silent and enduring, waiting for the next curious mind. The green patina catches the light. The tiny teeth hold their place, and across 2,000 years the message is still clear. Imagine a time far beyond our own. A lone figure walks across a landscape of crumbled concrete and twisted metal. They find a massive dome cracked open, its interior dark. Nearby a huge dish lies tilted, its surface eaten by rust, and in the rubble a small dark rectangle, a smartphone, its screen forever dead. In this future, our digital world has decayed. Hard drives are silent, servers are dust. Plastic has crumbled under centuries of sun and rain. Only stone, concrete, and some metals remain. The knowledge that made our world function, the code, the manuals, the constant flow of information has vanished completely. What would a future mind make of the shells we left behind? They might see a dam not as a power source, but as a massive religious terrace built to honour the river. A particle accelerator might become a ritual tunnel, a place where ancients sent offerings into the earth. Our windowless data centres, humming no more, could be interpreted as sacred vaults, where the most precious objects were stored in darkness. They would guess, just as we guess about the pyramids and the polished caves. This is the same pattern we traced across the ancient world. When the chain of knowledge breaks, when the teachers and the workshops vanish, the physical things that survive become mute. The instructions disappear first, the objects stay. And without the instructions, the objects become mysteries. We are not just observers of a lost past. We are the future's lost civilization in waiting. The gap between an ancient bronze gear and the people who no longer understood it. That gap will separate us from those who come after. Our own Antikythera mechanisms are already being built, sealed inside devices that will one day go dark forever. This changes the meaning of every object we have studied. The Antikythera mechanism is no longer just an ancient computer. It is a preview, a corroded warning from a world where the knowledge chain snapped. The stone at Puma Punku, the polished granite of Barabar, the iron pillar that wouldn't rust. They are not merely puzzles, they are mirrors. They show us that technical worlds do not have to vanish in a single dramatic catastrophe. They can simply stop being understood. And so, if one broken machine from their world, a handful of bronze gears pulled from the sea, could reshape our entire understanding of what ancient people knew, then we must ask ourselves, What single fragment of our own civilization, found in the rubble of a future age, would do the same for them? What object would they hold in their hands and whisper, "We did not know they could do this"? It stands now in a glass case, under museum light. The Antikythera mechanism is smaller than most photographs suggest. A lump of corroded bronze, a confusion of green and grey. The gears are delicate, fragile, their teeth worn soft by 2,000 years of salt and stillness. Nothing about it moves anymore, but that stillness is not silence. This one object, this broken machine from a Roman-era shipwreck, has quietly undone a simpler story. The story that says ancient people only observed the sky, that they built monuments but never compressed the heavens into a box of interlocking wheels. The mechanism does not shout, it simply exists, and that existence asks a question no museum label can quite close. Where is the rest of its world? The machine was not a miracle born alone. Behind it stood teachers and apprentices, failed prototypes and worn-out tools, workshops where generations learned to measure the sky in brass. Almost all of that has vanished. The mechanism survived only because it sank into deep water, where human hands could not melt it down for something new. It is a message written in the negative space around it. Look at what is missing. We have followed that negative space across oceans and centuries. The shaped andesite blocks of Puma Punku, cut with a repetition that suggests not just labour but a codified design. The polished granite chambers of Barabar, where stone became almost liquid under patient hands, altering light and echo until the room itself became an experience. A Roman cup that shifts colour from green to red, its glass holding particles too small for the naked eye. A recipe that worked long before anyone could name the science. An iron pillar in Delhi, standing through 16 centuries of monsoon and dust, its surface carrying a protective chemistry that the smiths may have understood only as a practice passed from master to student. The Great Pyramid, whose scale still makes the burial explanation feel small. A map drawn in 1513 that openly admits it copied older sources, carrying coastlines and distortions across time like a damaged memory. Circles of stone in England and passage graves in Ireland, aligned to solstices and star patterns, as if the builders were trying to write a message that could be read by anyone who noticed the sun. Each of these is a survivor from a broken chain. They do not prove a single lost empire. They do not whisper the same secret in the same language. But together they point towards something quieter and more unsettling. The past is not a solved book. It is a partially burned library, its surviving pages scattered across continents and millennia, most of the volumes gone forever. That is not a failure of evidence. It is a condition of civilization itself. Knowledge lives in fragile media. It lives in the hands of a craftsman who teaches an apprentice, in the wax tablet that melts in a fire, in the papyrus scroll that crumbles in damp air, in the oral tradition that dies with the last speaker. When those chains break, the knowledge evaporates. What remains are the hardest objects: stone, bronze, the occasional glass cup, and the questions they refuse to stop asking. The ancient world was not primitive. It was different. Its intelligence was not less than ours. It was embedded in systems that time, water, and collapse have erased. The Antikythera mechanism is not proof that the ancients were secretly modern. It is a reminder that modernity is only one way to organize knowledge, and that even the most sophisticated understanding can disappear if the chain of transmission snaps. We have seen what can vanish. We have seen what can survive. And now a quieter question rises, not about the past, but about ourselves. If one broken machine, pulled from the sea, changed how we read the ancient world, what single fragment of us would change the future's idea of us?